Okay, I guess we'll get started and people can get caught up as we go. So good morning / afternoon for everybody. Thanks so much for taking the time to participate in today's QIC webinar. My name is Vince Puglisi from MTE Consultants in Kitchener, Ontario, and I'm going to be your moderator for today. Today's session is titled Difficult Ground Conditions from a Trenchless Contractor Perspective, and it's going to be presented by Kyle Verwey from Earth Boring. For those of you who are new to QIC, I'm just going to take a moment to provide some information. And for those of you who've been to a few of the sessions and have heard this information, you're just going to have to hang on for a second, and I'll make it brief. So QIC, Canadian Underground Infrastructure Innovation Center, is putting on these bi-weekly live webinar series from September 15th to December 8th. If you want to see the full schedule, you can go to qic.ca. And so what is QIC? So QIC is a cross-Canada hub for research and education in underground infrastructure. It's located and based out of the University of Alberta. And QIC is a membership-based organization that involves stakeholders, including municipalities, contractors, owners, and others, to identify pressing issues facing the underground sector. Next. QIC stakeholders represent all the underground infrastructure domains, including water, wastewater, transportation, gas distribution, energy, power, and telecommunications. These sectors face similar challenges related to the construction and maintenance of underground infrastructure. Go. Membership, if you're interested, is open to manufacturers, suppliers, contractors, consultants, utilities, municipalities, and nonprofit agencies. So basically everybody. You can become an official partner with the University of Alberta, and it's a really good way to get access to different groups and forums. If you're interested, you can go to qic.ca/memberships to learn a little bit more. So we're going to get started the presentation soon. I just want to quickly introduce Kyle Verwey. Kyle's worked both in the rehabilitation and installation sides of the trenchless industry. His 12-year career industry has allowed him to develop a wide range of unique experiences and skills. Having worked personally with Kyle is one of the best in the business. He's always open to good conversation about the type of work that they do, and he's super busy. So I'm really grateful that he always takes the time for me, and he's taken the time for you guys today. So I really appreciate it, Kyle, and I'll let you take it away. If you have any questions, we'll have a Q&A at the end of the session. Please put your questions in the chat, and we'll hopefully have some time for questions for Kyle at the end. Thanks.
Awesome. Thank you, Vince, for that introduction for both QIC and myself. So today we're talking about difficult ground conditions, and I wanted to do a quick overview of different soil types and how they relate to trenchless technology. And then I'm going to go through some of the pitfalls of different methodologies of new installation with respect to the soils. Then I'm going to talk a little bit about Geotech Reports and GBRs and how you get that information and how it's ultimately presented to designers and contractors. And then I just want to kind of finish up with how we move from soil conditions to difficult conditions and differing soil conditions, and how that all gets wrapped up as you complete or start or work through a project together. I preach this in all my presentations. Literally, it's one of the first things I bring up at all times, and I know most other presenters on trenchless technologies also present this, but soils are the most important thing when talking about and designing trenchless technologies or trenchless crossings. So you can, but by describing what your soil conditions are, you can then choose what methodology is most important. There are other factors that go into that, whether it's distance, or diameter, and other micro considerations, but soils is a huge and critical part of this. There's a lot of key indicators that you get from a geotechnical data report, such as soil classification, Tunnelman's classification, the cohesion level of the soil, the hardness of the soil, whether it be through SPT values or RQD and UCS values, where the water is, and what sort of consistency you have. So it's very important to have that information when you're starting the whole project, and as you work towards getting to the point of designing or construction, having a strong and confident knowledge of your soils is very, very important. So one of the things I really wanted to focus on there is the USCS versus Tunnelman's classification, because the Tunnelman's classification, first developed by Terzighi and then was modified by Hewer in earlier this century, or I guess in the last century, was designed to help big open face tunnels and how those conditions will impact those big tunnels. So those classifications are typically just passed down to smaller utility trenchless applications, whether it's directional drilling or auger boring or microtunneling. And while they do have a lot of carryover, they're not always applied properly because sometimes they don't directly relate. So the United Soil Classification System is a really good way of describing what soil type you're dealing with and the typical attributes of those. And that typically meshes with the Tunnelman's classification, but when you do have a difference between the two, they don't always mesh up. And then when you're utilizing different technologies, whether it's by designing your cutter head or picking your drill fluid, you have to kind of anticipate both of those to put them together to get the right product and the right system for your trenchless crossing. So in any situation, there are certain combinations of soil types that can be problematic. Just going by the USCS or just going by the Tunnelman's classification, it may seem like the soil conditions are pretty good. But if you kind of combine the both together, you realize, hey, I have this soil that has a high blow count, so it should be stable. It's a non-cohesive material, but if it's wet, it may be running. But again, if you're dealing with a certain type of trenchless technology, whether it be directional drilling, microtunneling, auger boring, pipe ramming, then that could be a good thing, or it may be a bad thing. If you're auger boring, if your soil's raveling, it's a bad thing. But if you are microtunneling, and if you have a raveling soil, it could be a good thing because you might be expecting faster advancement rates. So exactly from that, I just want to segue into the different major new installation technologies and how those technologies are impacted with good conditions and where their pitfalls are in bad conditions or difficult conditions. So HDD is great in homogeneous material. You can deal with a difference of material, whether it's going from an overburden into rock or going from a softer, siltier material into a harder clay. You can utilize conductor barrels to make that transition. The only real pitfall with directional drilling is when you get into a situation where you have lots of loose cobble and gravels or boulders in your alignment, especially when you're dealing with on-grade shots or you're dealing with relatively tricky alignments. Auger boring, you need a stable face. There are a lot of add-ons that you can add to auger boring, pipe ramming being one of them, but there's guided boring, SBU heads, all this stuff you can add to enhance the installation method to make it work in different soil conditions. And I'll touch more on that in a couple slides. And then finally, microtunneling is great in almost every ground conditions. As long as you have the right tooling and fluid management plan. There are certain conditions that can cause issues, which I'll touch on in just a second when I get to that slide. But it's generally microtunneling is the best at handling any sort of combination of soil conditions. However, it comes at a price. So more detail on directional drilling. Directional drilling typically uses drill fluid, which is usually made up of bentonite, to support the bore path and move cuttings. It's great in homogeneous conditions because it allows you to drill consistently and move that material without modifying things too much. You run into a big problem with directional drilling when you're running into cobbles and boulders and other obstructions, whether they be natural or man-made. And so this short video I'm going to show you in just a second is an example where we were drilling for a new water main, actually in Richmond Hill, and we encountered an obstruction. And it turned out we thought originally was a boulder. With directional drilling, sometimes you'll just kind of steer around it and the reamer hopefully will push it out of the way later. But we discovered that this much larger than expected boulder could not be removed by excavation due to all the shallower utilities. And so we had to dig a small hole to get it out of the way. And I'm just going to play this video quickly, hopefully. So the only way for us to get this boulder out of the way was for us to vac a giant hole beside where it was sitting and then drop it into that hole so it's out of the way of the actual drill alignment. So again, cobbles and boulders, big problems. A nest of cobbles or even very, very clean, if you will, gravels can cause almost as bad of problems as large boulders, especially when you're dealing with grade sensitive crossings. So as I mentioned before, you can transition from two different materials, even though we prefer to be in homogeneous conditions. What we can use when we have a very significant difference in material, whether it's a silty cohesionless material into a shale or a bedrock, we use what's called a conductor barrel, which is shown in this bottom picture here, where you take a casing and you install it by auger boring or pipe ramming to get you into that harder material at the bottom. And then you can use appropriately designed drilling heads as well as drill fluid to go into that harder material and drill appropriately using that tooling. Because again, that more aggressive tooling that's good for the hard material may create big washouts and big sinkholes in your softer material above. So the conductor barrel holds that all together. So moving on to auger boring and pipe ramming. Auger boring is pretty good at dealing with most soil conditions, and you can use certain add-ons, whether that be pipe ramming to go into soft graveling soils or guided boring to go into grade critical shots that may cause your casing to drift a bit. And if you're into a hard rock situation, you could use an SBU head, which is great for cutting into rock. Using these different add-on or enhancements to auger boring, you can get through most soil conditions. One thing to consider, if you're not using an SBU head, it can get through boulders and cobbles, but they have to be at least 1/3 the size of the casing so that the auger can actually pick them up and bring them back through the tunnel. If you do have to deal with larger boulders or obstructions, then you have to manually enter the casing and remove them by hand. As I noted before, nests of smaller cobbles or smaller boulders can cause almost the same issue as a big boulder in the way. Even with pipe ramming, usually the pipe hammer with the enhanced cutting edge on the lead casing can burst through boulders and cobbles. Sometimes if you're in really bad conditions, and this happened to us actually in Guelph a couple of years ago, the nests of cobbles were so bad that it folded the lead edge of the casing in upon itself, so that the whole bore had to be abandoned. Luckily, we were across the tracks at the time, so we just moved the reception shaft up a little bit and it worked out okay. So finally, for microtunneling. Microtunneling is great at dealing with all soil conditions, assuming you have the proper cutting head and the proper slurry mix, and it depends what you're using and what situation you are. Most of the time, you use just water to inject into the face, and then that material will mix with the cuttings and become a slurry. If you're in clay, you'll add polymers to break up the clay. Sometimes if you're in other sandy material, you may add some other material just to help float that sand out of the crossing. So the main problems where you run into with difficult conditions is when you're transitioning between soil types with microtunneling. Because if you don't have enough angle to punch into from a soft material into a hard material, you may have to fight for a significant period of time to get that alignment on where you need it to be. 99% of the time, microtunneling is done with very fine grade accuracy. And so making sure you hit that transition and you're not deflected by the soil is very important. Also, with the casing or the product pipe behind the microtunnel, you have to be aware that in certain conditions, if you've got, say, a hard ground with nested cobbles or boulders, they can be in a position where they pinch in such a way that they would crush concrete pipe. If it's just straight reinforced concrete pipe, you can circumvent that if you have a steel casing where it just might only dent the casing, or you can do steel line concrete pipe, which again works really well in very, very bad conditions. So moving on to how do we get our soils information? Almost everyone here, I'm sure, has seen a geotech report before. They come in different varieties of quality and scope. Sometimes for certain developments, they don't consider a trenchless crossing and they just do their 6 or 9 or 12 boreholes all around the property to get a representative sample of whatever foundation they need for the building. Sometimes the geotechnical reports are very specific for a crossing and they do boreholes at certain intervals at the appropriate depth, appropriately spaced away from the actual bore path so you don't have issues. And all those, all the different geotech data reports are good information to have regardless of the quality, just because it will give you a representative bit of information that you can base or we as a contractor can base our recommendations on. It's always preferred when the boreholes go down to the depth of the crossing, and if they're close to the crossing, that's excellent as well. So for the more, maybe complicated is not the right word, but the more trenchless focused project, we've seen a lot of geotechnical baseline reports in the recent past. These reports are great because they even out your bids. So in the geotechnical baseline report, it could say, based on these soil conditions and based on the experience in this area, you should expect to hit 5 boulders in 10 meters of tunneling, whatever the ratio is. And that's great because now we can plan for that and we can make sure we have the appropriate tooling. And if there's a situation where you have to negotiate, hey, these are different ground conditions, we can say, well, the baseline report says 5 boulders. So we only hit 5 boulders, great. But what happens if you hit 6 boulders? Then is that a legitimate extra cost, or is it something we have to work through? On the flip side, what if we only hit 4 boulders? Is there a credit involved? Tough to say. Then beyond that, there are specific memos or reports that will take the data from a GDR and a GBR, put it together and say, hey, for this trenchless crossing, we, the designer or specialist engineer, have reviewed the situations and we provided this nice breakdown that says, these are the main trenchless methods. Here's what you could use. Here's the pros and cons of using this. Here's the pros and cons of using this. We recommend based on this, you should use that. And that will take, sometimes the specifications will take that memo or report and use that to base the specifications for the contract. Putting all those together is how we, from a contractor, get to see and bid on our projects. Again, there's a lot of projects that are designed and built really well around the trenchless technology and the trenchless crossing, but there's a lot of projects that they just realized that they had to do a trenchless crossing because Region X said, no, you can't dig up my major road. So to connect it to your water main, which is on the other side of the road, you have to cross that. And now they have to add in that extra bit about a trenchless crossing, even though they didn't do a specific crossing design detail for it. So the last thing I want to talk about on the investigation reports are boreholes, monitoring wells, and test pits. Boreholes are great because they provide an awesome snapshot for the geological conditions and are good for qualitative data to say, hey, this is where the grain size analysis come back. This is what kind of blow counts you have, how hard the ground is. And monitoring wells are kind of a step up where, hey, we did a borehole. Now we're going to put in a monitoring well, check the water level. And so we can make sure we have a good representation of where the water is going to be, assuming the monitoring well is installed properly. One of the things that the boreholes don't give is they're very small. They're 4 to 6 inches in diameter. They only provide a very small snapshot of what is in your alignment. And if you have that borehole right where it is, there could be a great big giant boulder literally 2 inches away from that borehole, which you'll never see because you just took that one little snapshot. Also, boreholes are tough to provide good data on how that soil reacts. When you extract your borehole, you've got your case sample. Sometimes it's in a good condition, sometimes it's washed out. It's very tricky to determine and provide that information in a snapshot. If you do provide test pits, then it's great to see how that soil actually reacts when you dig it. If you've got a great big pit, you dig a couple holes and you see it start sloughing in, you may not see that or capture it in such a way in your borehole log where your test pit will show that really, really accurately. So finally, I want to talk about differing conditions, because differing conditions can make things more difficult, or not, but it depends on the trenchless methodology and how you're dealing with the trenchless crossing in its entirety to see what the situation is. A lot of the times, because test pits weren't done, or you're dealing with areas that have typically never been dug up before, hence the trenchless crossing, the soil conditions here are a lot of the times unknown, or they could change for whatever reason in this particular section. So when there is a change, when you're in construction and you've gone past the point of design, there are issues that they need to be resolved. Those issues depend totally on what's in the way. Could be boulders, could be tons of cobbles, could be you found garbage fill, concrete, steel. You could run into situations where you've got nice dry soil, kind of like this picture here. We've got nice, beautiful dry soil here, but then we went a little bit further and we hit this super sloppy material that runs out of the casing and potentially creates a sinkhole. So how can we resolve these differences together? So sometimes differing conditions are not that challenging. It's just a bump in the road. Maybe it's a little tweak to the methodology. Maybe we just have to keep the augers in and reverse them at the end of the day so the material won't flow. Or maybe we just need to trip out and use a different drill head on the directional drill. Having that information and proving that information from a contractor is tough because it's underground. Sometimes you can't see it. For example, outside of a microtunnel machine, you can't really get there to see it. So how do you prove that these conditions are different? A lot of the times owners and consultants will say, hey, can you just do your own geotech report and prove to us that it's different? Sometimes those are good representations, sometimes there's not. One of the things we like to say is, hey, just so you know, we're taking the world's largest borehole horizontally directly through the alignment. It's the tunnel. And having an understanding of how the microtunneling solidification system works, or how the directional drilling soil transfer works, or how the Augerbore spoil buckets work, you can see why these conditions are different than what was in the geotech report. And so going through that process can be a challenge because ultimately nobody wants to pay for this change, and which is totally fine. The contractor doesn't want to pay, the consultant doesn't want to pay, the owner doesn't want to pay, but it's a different condition. It's not necessarily fair that this is now a change to the contract conditions, and working together with all parties can make everything a lot easier and better to get this sorted out. One of the things that someone said to me a long time ago was, well, why didn't you catch this when you were bidding it? Or what did you bid on? We bid on what information was provided to us. Typically for a tender close, we've got, say, 2 to 6 weeks of time to review the details. We don't have the luxury of going out and getting a geotech report or getting a third-party contractor to go in there and do this extra analysis. And a lot of the times the design phase has a huge length of time they could do this extra investigation on. So it's not necessarily anyone's fault or any situation that causes that, but everyone just needs to be aware that you need to work together to get this resolved, because there's many factors at play here that cause these ultimate issues, and it's nobody's fault. The ground is what the ground is, and not being able to identify it in advance. This picture here is an example where this bottom layer is shale and this top layer is a silty sand, and the design had us working in silty sand for the entire crossing. But then when they excavated the test pit or the shafts on either side, they found we were half in the shale and the actual bore profile was right here. So we had to change our methodology. Ultimately, everything did not work very well because we were bound by specifications of a contract. And all in all, it was a challenging situation. This picture right here is an old one. Some of you may have seen it before, but this is a picture of a tunnel that we had to, the Geotech report for a development, put in a number of boreholes and identify the soil. Nothing surprising, just a normal soil type. When we went in to start excavating this tunnel, we ran into wood, and not just small bits of wood. The previous owner 50 plus years ago had a forest on his land and just chopped down all the trees and buried them with fill. And so when we went in there to tunnel these, the entire tunnel alignment was filled with huge chunks of wood, and they were just massive fallen trees. And we had to go in with electric chainsaws and physically cut out all these trees out of the tunnel alignment to get this in the right place as per the design. So again, these conditions were there. They would have definitely been identified by a test pit, but they were completely missed by a geotechnical bore log, and it was a huge additional cost just because of the change of method required to get these out. So the take-home point of my presentation is all stakeholders need to work together to have a successful project when you have difficult ground conditions or when you have regular ground conditions. When you have a change of conditions, having that communication between all parties is very, very important, and it creates good things to happen when everyone can work together and come up with a solution together. Great geotech is critical for this sort of thing. Reviewing your reports, getting proper information for trenchless crossings, sharing that with the contractor. Obviously, it's done in the tender phase, but even reviewing it before, I get emails probably 3 times a week from consultants saying, hey, what do you think about this crossing? And every time I ask, please send me the geotech, send me the geotech, send me the geotech, send me the geotech, because that's the most important part that we have to review before this. Anyway, that is all I had for today for my presentations. I know there's a couple questions. If anyone has any other questions, please put them in the chat. I'll be happy to answer them. And Vince, there's a couple more slides for you. Just promoting the next couple of presentations in this web series.
Awesome. Thanks a lot, Kyle. And I can verify that the first question he asks me every time is, can you send me the geotech report? So that is 100% true. So I'll get to the questions in a second. The next session, I guess, is a journey towards reconciliation as an engineer, November 24th. And then December 8th will be the last session, I guess. And so hopefully you guys will enjoy this one and you'll sign up for those sessions. So let's get to some of those questions while we have some time. So Kyle, for microtunneling, can cutting heads be removed and replaced with different cutting heads based on soil conditions?
So in mid tunneling, the head itself cannot be removed unless you have a rescue shaft. That being said, tooling of the head, when you're dealing with a head that is 1200 millimeters, for example, an AVN 1200, so the nominal pipe size is 1200 millimeters, is big enough for access, and you can get into the head and change the cutters and the scrapers. The one thing to consider with that is in certain ground conditions, if you have a very high water table or very aggressive water coming in, it's very difficult to get to the face to do those changes without those controls. So short answer is, to change the whole cutting head, no. To change the tooling, yes.
Okay. Would ground penetrating radar provide additional soil information?
Ground penetrating radar is an interesting technology because it's very good at identifying anomalies. Those anomalies, though, are very difficult to interpret what they may be. You could identify a boulder, you could identify a void. Ground penetrating radar picks up the difference in ground consistency. So it is nice at determining where a soil transition layer is, if it's a stark transition, but it's very operator subjective. So your team at analyzing the GPR is very critical on identifying that stuff. So is it helpful? It can be. Is it recommended? From an initial perspective, no. I'd say if you have a known issue that you're trying to resolve, then it is a good technology to utilize.
I guess that kind of goes into the next question. Are there actually geotechnical reports that estimate an exact number of boulders, cobbles? I think you mentioned sometimes that goes in the tender, whether there's 5 or 6. I guess they said they've seen typically something akin to cobbles may be present. And when you're looking at it, how do you bid on a vague statement like that?
So yes, we have those vague statements all the time. The short answer for that is a geotechnical data report will never present that. However, a geotechnical baseline report will sometimes do that. And we've seen when that's going to be a concern, it will say, hey, you have expect 5 boulders in 10 meters. That example that I gave, that's very similar to what was actually written in the actual geotech report. You should expect X number of cubic meters of boulders in your tunnel alignment.
Mm-hmm.
So how do we bid on a vague statement like that? We take that into account when we're considering our risk. If we're dealing with an on-grade directional drill shot, that will make the risk significantly higher. If it's for a long microtunnel, not the biggest concern, because we're always considering with microtunneling in Ontario having a mixed face cutter head to deal with cobbles and boulders. So we account for it through other means and methods, but the actual outside of a geotechnical baseline report, there's not really a way to get around that without considering everything else on the project.
Okay. Here's a question. The onus for selection of an appropriate range of tooling for the geology is on the contractor. The owner expects contractor pricing to include risk of geological uncertainty. Why should the owner entertain any change order?
Good question. So for this, it will be, it's you have to take a step back. So when you're designing a crossing, it depends on the application of the crossing to choose the appropriate technology. Because, for example, you could have a sanitary sewer that you need to install across a road. In the sanitary sewer, the owner says install by the owner or the designer says install by trenchless. So could I install by directional drilling? That is by far the cheapest of all the trenchless technologies. But are the soil conditions valid for that? Maybe, maybe not. Maybe there is a specification that say, well, you have to install a steel casing. Okay, so now we have to do it by auger boring. And if you have no geologic information, do I base that off no information, or do I base it off the nearby boreholes? How do you decide what to do? Because otherwise, I have to bid it super high to account for all my risk. And if I don't bid it, someone else might decide that that risk is less. And if that risk is less, then you will get a maybe less scrupulous contractor to come in and do it for cheap, but then start hounding you for change orders right off the bat. The big challenge with this particular question is if you're saying contractor, do whatever you want, then you're going to get the lowest bid. And then if something doesn't work, then the crossing is not completed, that contractor walks away. If you have a contractor that knows what they're getting into, they're giving you a fair price based on a number of assumptions. And one of those assumptions could be, hey, we've given you no information. So that price is going to be much higher. So it's a very tricky question, because if you give no information, your prices are going to be higher because the contractor has to assume a lot of things. But as soon as you start giving information or restrictions or specifications, they are bound by those contractual obligations to fit into that mold, and conditions could change that will impact that. And so the owner owns that ground. So whose fault is it other than the owner to say these ground conditions are different? For example, what if you had a buried culvert in the middle of this tunnel alignment? Is that the contractor's fault? Is that the owner's fault? Did they even know about it? Again, so I know this is not a good answer, because we could talk about this for hours, but
Yep.
The owner is ultimately responsible for their project. And if they can provide enough information that they get a good price from a contractor that qualifies their, we assume this, we assume this, we assume this, then there can be a justified case to provide a change order in conditions that are reasonably different than what was expected. But again, it depends on what was provided initially. So it's anyway, it's a long-winded conversation. I'd be happy to chat about it more at another time, but
Sure. Okay.
sorry if
No,
that doesn't
it's all
answer.
right. No, I totally get it. Do any project tenders make allowances for the unknown soil conditions to make cost risk more acceptable? Kind of building on what we were just talking about.
Sometimes, some contracts will have tender items for boulder removal. Some certain OPSS have conditions for boulder removal. Contracts have line items that say extra over for boulder removal or extra over for rock removal. Also, a lot of contracts, most contracts will have a contingency item that could be applied to something like this. But when it's not distinctly said in the contract, hey, these are the conditions you're going to run into, then it boils down to being, again, a fight with the contractor and the owner to say, hey, is this an agreeable extra? And that's where having those baselines is great, because you know you have a quantifiable level to say, hey, this is what we're expecting to hit, this is what we actually hit. It's if you don't have that, then you do have a challenging situation to agree upon a different condition.
Okay. There's a couple of comments in here about ground penetrating radar, just saying that there's, sometimes the issues in the interpretation, and then just pointing out that it's not efficient in high plastic clay soil like you have in Alberta. So I would imagine that it doesn't work too well in those conditions.
Yeah, and I 100% agree. GPR is good at identifying anomalies, but it 100% agree. It boils down to the interpretation.
Mm-hmm. Where can you find existing reports on subsurface soil conditions at a particular site?
So, the Ontario Geological Survey has a historical Google map. Forget exactly what it's called. Hold on, I will pull it up. But basically, it is a database of historical boreholes for the entire province, and it plots it onto Google Earth, and it allows you to look at these historical boreholes. Again, they're very rough because it's not like a true borehole, but it gives you a representative sample of the conditions in that area. Mm-hmm. So the Ontario Geological Land Surveyors, I think it's land surveyors. Hold on, let me try and find it. But anyway, yes, it exists. It is found online. You can review it in Google Earth. Outside of those existing conditions, most projects do require a geotech report for their site for one reason or another. Any sort of structural design will need a geotech report to base that on. The owners or stakeholders should have that information. But if you're looking in general for kind of a new site, this database that is available online for free is a good place to start to get a rough representation of those conditions.
Okay. All right. In your opinion, do you think the trenchless industry conducts sufficient amount of field laboratory tests? I feel like we are strongly relying on the SPT. However, I do not see the other types of advanced tests commonly seen in other practices. Just want to hear your opinion on this one.
Okay, thank you. So the trenchless industry is a weird concept because most geotech reports are provided by the owners with respect to their greater projects. When you do consider small crossing reports, they typically provide SPT data, 100% agree, or RQD and UCS data. Some more, they usually provide a grain size analysis and a chemical analysis as well, but those are less representative for trenchless crossings. typically when I look at a geotech report, I look for SPT, I look for RQD and UCS in rock, and I look for where the water level is and what the classification is, because those will give me a good representation of the soils that we're supposed to be dealing with. The other thing I always look for is the driller's logs or driller's notes. If they say augers are grinding, or if they say refusal, is that bedrock or is that a boulder? Is grinding a bunch of cobbles or a little bit of gravel? Will it come back in the sample? It's a what they do is a good representation. If you're talking about, say, triaxial testing for clays, it's not super appropriate. A chemical analysis of clays would be more appropriate, because then we could choose the right fluids to break down that clay faster. So to answer your question shortly, I would say the geotech industry is doing a pretty good job at field and laboratory tests. I would prefer to see more test pits that would give a complementary information to the borehole logs. That would be my biggest suggestion, to do something like that. Not always possible. If you're doing a super deep tunnel, you can't dig a test pit 15 meters deep, but they're getting a good representation of that is very good.
Okay, thanks. Keep going here until someone tells me to stop. Would you, as a contractor, recommend having a GBR for every trenchless project to understand the risks and share them with the owner?
Would I recommend it? No, because a lot of trenchless projects, the trenchless portion is a tiny percentage of the greater project. When you do have trenchless projects that are the bulk of the trenchless project, the bulk of the project is trenchless, yes, because it makes dealing with those conditions a lot easier. But when you're doing, say, a short little culvert crossing, it's not, it wouldn't be worth your dollar value, because your GDR will provide pretty much the recommendations that are going to be in your GBR. The only thing your GBR may add is those quantifications about, hey, 5 boulders in 5 meters, or whatever that number is. Bigger projects, highly recommend. Smaller projects, not usually recommend, is the short answer there.
Okay, Kyle, I'm going to give you one more question because I like this one.
Okay.
What are some of the challenges associated when working below a groundwater table, or does trenchless installations make these challenging soil conditions for open cut methods a non-issue for trenchless?
So certain trenchless technologies do great in below the water table. So directional drilling is excellent under water tables, because it relies for the borehole to be wet the whole time anyway, filled with drilling fluid. Directional drilling also creates a filter cake, typically when it's in softer soils, to ensure that that borehole is protected. With microtunneling, if you're below the water table, the system is slurry pressure balanced, so it works really well in groundwater conditions, because it just balances that force. With auger boring, if you are in a wet condition, as long as the soil's stable, so it has a lot of cohesion, it's not a big deal. If you are in a less cohesive material, then it will create some issues. That's where you could switch to pipe ramming, where pipe ramming maintains a much bigger soil plug, so it prevents that flow of material where applicable, but it's not the be all end all. So the biggest challenge actually with high groundwater tables is putting your shafts in. So you have to make sure your shafts are watertight, whether that's secant pile shafts, caisson shafts, or sheet pile shafts. As long as you make those watertight, and then make sure you have an appropriate seal to go in and out of your shaft with your technology is set up properly, you have no issue. So yes, trenchless is great at dealing with works or conditions that are below the groundwater table, and it does solve a lot of the open cut issues, as long as you consider some of the limitations of trenchless technology. So for example, on grade directional drilling, you need at least minimum 1% grade if you're in overburden type material. hopefully that answers that question.
I think it does. I think that that's going to be the end of today's session, Kyle. Thank you very much. Really appreciate your time.
Yeah, no, thank you very much, Vince, for moderating this, and everyone who attended, thank you very much. If anyone has any follow-up questions, feel free to shoot me an email. I'm happy to discuss this sort of thing all the time. And looking forward to seeing you at the next CUIC event.
See you.
Okay, take care, everyone. Have a great day.
Bye.